Okay, in this video, let me take you through balancing redox reactions. So in this example here, I have I minus plus ClO minus going to I3 minus and Cl minus. In the first step, you want to create two half reactions. So focus on iodine here. We've got I minus going to I3, so that's our first half reaction. For the other part, we can see that ClO minus goes to Cl minus, so that's the other half we want to work on. For step 2, we want to balance the element. Don't worry about hydrogen or oxygen yet, so we're going to focus on iodine or chlorine. So if we look at I minus going to I3 minus, we need 3 iodines on the left, so we put a 3 in front of the I minus, so now there are 3 I's on each side. For ClO minus going to Cl minus, the Cl is balanced, so we're going to skip that step here. Next, we balance O with water. For our first half reaction, I is going to I3 minus. There's no oxygen, so we skip that step. For the ClO minus, we need an O on the right, so we add H2O on the right. Step 4, we balance the H with the H plus. Obviously, there are no hydrogens in this left reaction, so we just skip it. If you take a look at the half reaction on the right, we need 2 hydrogens on the left because H2O has 2 hydrogens, so we add 2H plus on the left. Now we're at this point where we need to think about balancing the charge with electrons. There's a -3 charge on the left and a -1 on the right for this reaction here involving iodine. We need to add electrons to the more positive side. -1 is technically more positive than -3, so we add 2 electrons to the right. For this next equation, we have a +2 on the left in total, and a -1 on the right in total. So we add 2. Actually, it's a +1 on the left in total, and it's a -1 on the right. Anyways, we add 2 electrons to the left, and that completely balances the charge. Okay, so there's overall a -1 charge on each side. Okay. Now, what we want to do here is go ahead and make sure the electrons are the same by finding a common multiple. Each of these reactions involves 2 electrons, so we can skip step 6. We add the two halves back together again, okay, by just combining all of the different pieces here. And all the left stuff goes on the left, all the right stuff goes on the right. Okay, so this is our net reaction. Now we want to look for common terms that can cancel. 2 electrons are on each side, so we can cancel those. And we got the overall answer here. Here's an overview of the process.